So again, today we are talking about adding and subtracting rational expressions that have unlike denominators. But today, unlike Tuesday we discussed these unlike denominators, but our denominators were monomials. Today we're going to talk about what to do when the denominators are binomials or even trinomials. So we're going to do more examples here. The process is still going to be the same. Remember that to add any two fractions, regardless of how hard the problem is, you have to get a common denominator. And then once you have a common denominator, you just add like terms across the top. You add the numerators. So this has a couple layers, a couple different levels of problem within these notes. So pay close attention to the examples today, because when you go into Delta Math, it's going to ask you to complete 5 problems, but there are 3 or 4 different problem types. So you need to be aware of all of them in order to be prepared for any of them. So on our first example here, we have 3x plus 2 over x plus 7 plus 1 over x plus 5. Okay, so what we're going to do is we have to get a common denominator. Well, the common denominator would be a combination of our two binomials. So the first thing I suggest you do is you go in and you put parentheses around any binomials or trinomials in the numerator or denominator, because you have to keep in mind that those things cannot be split up. Okay? Our common denominator here is going to be x plus 7 times x plus 5. Okay, it is going to be x plus 7 times x plus 5. So we need to get both of these fractions to be over x plus 7 times x plus 5. So if we look at what we have, the first fraction has an x plus 7, but it needs an x plus 5. So we need to multiply the bottom and the top of that first fraction by x plus 5. So that would give us x plus 5 times 3x plus 2. And then the second fraction, it has an x plus 5, so it needs an x plus 7. So we have to multiply the bottom and the top of that fraction by x plus 7, which would give us 1 times x plus 7 over x plus 7 times x plus 5. Now, generally speaking, because we do not actually add the denominators together, we are not going to multiply out the denominators. We're just going to leave that in its factored form, x plus 7 times x plus 5. But we have to multiply out or FOIL or double distribute this set of two binomials here. So we need to do x times 3x, which would be 3x squared, x times 2, which would be 2x, 5 times 3x, which would be 15x, and 5 times 2, which would be 10. So we have to multiply those two binomials out. Leave the denominator alone. Just leave it as x plus 7 times x plus 5. And before we get off the thing here, I'll make sure that that is the case in Delta Math. But I assume, because I've never seen anybody ever teach this where they actually have to multiply out the denominator. Just leave the denominator alone. We're multiplying out the numerators here. So the other fraction, well, we just distribute that 1, which, 1 times x, 1 times 7, that doesn't do anything. So that would just be x plus 7 over x plus 7 times x plus 5. Then we are going to go in here and we're going to add our like terms. So we have a 2x, a 15x, and a 1x. We're going to add those together. So we have the 3x squared as its own term. We add the 2x, the 15x, and the 1x, because remember there is a 1 in front of that x. That is a total of 18x. And then we are going to add the 10 and the 7, because those are like terms, to get 17. That is over x plus 7 times x plus 5. Now, at this point, you are probably done. But you need to check to see, just like we had to do on Tuesday, can the fraction be reduced? So you would need to basically look at the numerator and decide whether or not that is a factorable trinomial, whether or not it can be factored, because if it can be factored, you might be able to reduce. And if you can reduce, you have to reduce. So we would look at this and go, oh, it's a not equal to 1, so we have to do 3 times 17, which would be numbers that multiply to 51 and add to 18. There are not any. There are no numbers that multiply to 51 and add to 18. So the top is prime. Since the numerator, it cannot be factored, that is our final answer, because that means that that cannot be reduced. Okay? So that is how we're going to be approaching these problems. And some of them will be easier than others, just like they have been. They were on Tuesday, just like they have been all year. Some problems will be easier than others. So I think I have a total of 8 examples here. I don't know that we will do them all, but we're going to do enough of them that I feel like you're getting the hang of it. And by getting the hang of it, I'm hoping that when you have questions, you're going to post them into the chat. So if anybody has any questions before we go to the next example, please post them now. In regards to the question that's already there, I wonder if you were doing the correct Delta Math assignment, because there shouldn't have been any that looked like this on the one from Tuesday. All right, so nobody's jumping at the opportunity to ask any questions, so we'll go to the next example here. Okay, here, this one is a little bit different, and the main reason it's different is because we have a difference of 2 perfect squares in x squared minus 25. So our first step would be to factor that. That factors into x plus 5 and x minus 5. So that would be the first thing we would need to do, is factor that binomial, that difference of 2 perfect squares. So once we do that, that shows us what our common denominator should be. Our common denominator should be x plus 5 times x minus 5. So our second fraction needs to be multiplied by x minus 5 in order to get a common denominator, top and bottom. So that would turn this into 1 times x plus 5, or 1 over x plus 5 times x minus 5, minus 7 times x minus 5 over x plus 5, x minus 5. So at this point, we need to multiply out the numerator, just like we did on the last problem. So we're going to distribute. Okay. And I'm even going to go a step further here, because this is subtraction. Remember, that subtraction symbol makes things tricky. So instead of distributing positive 7 here, I'm going to move that negative into this 7 and change this to a plus. So I'm going to distribute a negative 7 through there. And the reason being that once I distribute a negative 7 through there, I have taken care of the possible trickiness of this being a subtraction problem instead of addition. So that would give us 1 over x plus 5, x minus 5, plus negative 7x plus 35 over x plus 5, x minus 5. So at that point, and I'm hoping you guys can see all of that on your screen. Yep, okay. We're going to go in and add the numerators, which means add the like terms, which is only 1 plus 35. So that would give us negative 7x plus 36 over x plus 5 times x minus 5. We do a quick check to make sure that the numerator cannot be factored, which the only way it could be factored is if there was a GCF, but 36 is not divisible by 7, so there is no GCF, which means it cannot be factored, which means this is our final answer. Okay, so there's our second problem type where we have one denominator that's factorable and one that is not. Okay, our third example here is very similar to the first example. We have our common denominator should be x plus 5 times x plus 8. So the first fraction needs to be multiplied by x plus 8. And the second fraction needs to be multiplied by x plus 5 in order to get a common denominator. So that would give us x times x plus 8 over x plus 8 times x plus 5 plus 3x plus 7 times x plus 5 over x plus 8 times x plus 5. Now, same deal as the first example. Our next step is we need to multiply out the numerators, okay? So we're going to be distributing this x, and we're going to be foiling or double distributing, whichever way you prefer to think of it, that whole second numerator. So that would give us x squared plus 8x. We're going to, again, leave the denominator alone. So over x plus 8 times x plus 5 plus 3x times x is 3x squared. 3x times 5 is 15x. 7 times x is 7x. 7 times 5 is 35. So multiply out those numerators. And then we are going to add like terms. So we have 3x squared plus x squared. That would be 4x squared. We have 8x plus 15x plus 7x. I didn't quite get that out right, which would be 30x. And then we still have a plus 35 on the end because it doesn't have any like terms. Over x plus 8 times x plus 5. Again, we need to run a quick check to make sure the numerator is not factorable, and it is very, very rare that it would be, and that it would be factorable, and that it would be reducible. But the first time you don't check, it will be, and you'll get it wrong. So please make sure you check. So we do 4 times 35, which would be 140. There are no numbers that multiply to 140 that add to 30. So that is not a factorable trinomial, which means that is our final answer. Again, at any point in time, if you have questions, please post them to chat. If not, we're going to continue on to the next example here in about 30 seconds. So if you want a screenshot, grab it now. Okay. So here's our next example. This one is a little bit different, but not really. I mean, if we look at this, our common denominator this time will be x times x plus 7. So our first fraction is missing x plus 7. So we need to multiply the bottom and the top of the first fraction by x plus 7. And our second fraction is missing an x. So we need to multiply our second fraction by x. So that would give us x plus 7 times 3x plus 7 over x times x plus 7 minus x times x plus 3 over x times x plus 7. Same deal, we need to multiply out those numerators. So we start by double distributing, by foiling that first set. Again, I'm going to move this negative into the fraction and put it with that x, and distribute a negative x through the second fraction. So that would give me x times 3x is 3x squared, x times 7 is 7x, 7 times 3x is 21x. 7 times 7 is 49. Leave the denominator alone. Plus, negative x times x is negative x squared. Negative x times 3x is negative 3x over x times x plus 7. Combine like terms, so we have 3x squared plus negative x squared, which would be 2x squared. We have 7x plus 21x minus 3x, which would be 28 minus 3, or 25x, plus 49 over x times x plus 7. Again, we need to do a quick check to make sure there are no factors of 2 times 49, which would be 98, that add to 25. There are not. 98 is 2 times 7 times 7, so the only options there would be 14 times 7, which does not add to 25, or 49 times 2, which does not add to 25. So once again, we check, but it does not reduce, and that is our final answer. I hope this is going well. I know that these are harder problems, and again, this is not an ideal delivery system for instruction, but we're going to get through this, okay? We're going to go on to the next one here. If there are no immediate questions, again, you should be seeing a pattern to the way these are approached, because even though the problems all differ a little bit, they're all done exactly the same way. Get a common denominator, multiply out the numerators, add the numerators, reduce if possible. So here we go. Okay, once again, the denominator on this first fraction is a trinomial that is factorable. That factors into x minus 3 times x plus 1. So that should immediately tell us that x minus 3 times x plus 1 is going to be our common denominator, which means our second fraction, we need to multiply the bottom and the top by x plus 1 in order to get a common denominator. So that would give us 5 over x minus 3 times x plus 1 minus 5x times x plus 1 over x minus 3 times x plus 1. Once again, I'm going to move that negative into the second fraction so that I can distribute a negative. That takes away the chances of me missing a negative when I'm simplifying. So I'm going to distribute that negative 5. So the first fraction is unchanged because there's nothing to multiply out there. It's just 5 over x minus 3 times x plus 1. Then I have plus negative 5x squared minus 5x over x minus 3 times x plus 1. I'm going to add those together. Now there are no like terms in the numerators of those two, so really all I'm doing is rewriting this in descending order, and that shouldn't say to the fifth. That should say negative 5x squared minus 5x plus 5 over x minus 3 times x plus 1. Now this time the numerator is factorable in a way, okay? It is possible for us to take that negative 5 out of there, which would leave us with x squared plus 1x minus 1. Now the good news is that we don't need necessarily to do that because that still does not reduce, okay? But you need to be aware that it could happen. The numerator could be factorable and you might have to reduce, so you always have to check, okay? Again, that trinomial x squared plus 1x minus 1, there are no numbers that multiply to 1 and subtract to 1. So that doesn't factor. In reality, you can just leave the answer like this because it does not reduce. In theory, Delta Math should accept either one of those answers as being correct. I checked yesterday. Everybody doing okay? I know that I'm just sort of droning on and on here, so I hope that everybody is still engaged and paying attention. If anybody has any questions, drop them in the chat. We've got a couple more examples here. There's one or two more little twists that we need to talk about. Okay, so here's our next example. We've seen one like this one before, so this is more or less us looking at one that we've already seen. We need to recognize difference of two perfect squares in that second denominator and factor it into x plus 8 times x minus 8. What that tells us is that our first fraction, in order to have a common denominator, needs to be multiplied by x plus 8. So our first step would be to multiply x plus 8 into that first fraction. And I know I'm speeding up, but part of the reason I'm speeding up is because I've explained this part a couple times now, so we should be able to speed through it a little bit. Okay. Then we are going to multiply out the numerators. So we're going to double distribute or FOIL the top of the first fraction. That would give us x times 7x, which is 7x squared, x times 1, which is x, 8 times 7x, which is 56x, and 8 times 1, which is 8. Again, we're going to leave the denominators alone. There's no reason to change them. Minus 2 over x plus 8 times x minus 8. Now be very careful. What that means is you are adding negative 2. So don't lose that negative. Pay close attention to subtraction. We're going to go in and add our like terms. So we've got some x's and we've got some numbers to add up. So we're going to do that, which would give us 7x squared. Oops, what happened? Okay, there we go. Plus 57x plus 6 over x plus 8 times x minus 8. Once again, we need to do a quick check to make sure that this does not factor. 7 times 6 is 42. So we need numbers that multiply to 42 and add to 57. It is very unlikely that that's going to happen, and it doesn't. So once again, that would be our answer. Okay, our next example is one you need to pay attention to because it does have a new twist. So if you've got other stuff going on, this is a place where you should pay attention because this is one that is a little bit unique. And if you come across it on the assignment, it could cost you points if you weren't paying attention during this part, okay? So here's our next problem. Now the difference is that 3 is not a fraction. But 3 is a rational number, and we should remember that all rational numbers can be written as fractions. We can take 3 and we can write that as 3 over 1, which means our common denominator would be x minus 6. So what we do is we multiply the first fraction, top and bottom, by x minus 6. We get our common denominator, just like we have been. Which would give us this, okay? 3 times x minus 6 over x minus 6 plus 3x plus 7 over x minus 6. Distribute the 3 would give us 3x minus 18 over x minus 6 plus 3x plus 7 over x minus 6. Then we go in and we add like terms. Would give us 6x minus 11 over x minus 6. That does not factor, so that is our final answer. Okay. Okay, there's a couple more examples on here. I'm going to go through them. It's going to be a little bit quicker because at this point we've covered all the little twists and turns that can come up. I just want to do some more examples on video. Again, if you're not registered yet on Delta Math, you need to get registered. So you need to watch that video, please, that I posted on Tuesday and get yourself on there, because both Tuesday's assignment and today's assignment are on Delta Math. So you need to get yourself registered on there so that you can participate. Okay, it's free to register. All you need is my number, which is on Google Classroom. So here we go. Here's the next example. There's two left that we're going to do. So once again, we've got ourselves a trinomial here, which we need to recognize as being factorable. It factors into x minus 6 times x minus 5. So that means our common denominator is x minus 6 times x minus 5. And our first fraction is missing that x minus 5. So we need to multiply the bottom and the top of the first fraction by x minus 5. That would give us this. X minus 5 times 3x plus 5 over our common denominator, x minus 6 times x minus 5, minus the second fraction, 3 over x minus 6 times x minus 5. We are going to double distribute or FOIL the first example out, and I am going to move this negative into the second fraction. So that would give us, multiply that out, x times 3x is 3x squared, x times 5 is 5x, negative 5 times 3x is negative 15x. Watch those negatives. Negative 5 times positive 5 is negative 25. Over x minus 6 times x minus 5 plus negative 3 over x minus 6 times x minus 5. We're then going to go in and combine our like terms. We've got some x's there that need to be added, and we have some numbers there that need to be added. So that would give us 3x squared minus 10x minus 28 over x minus 6 times x minus 5. Once again, we check to see if that reduces, which it does not. So that would be our final answer. Okay, I forgot about this last example. So if you've stopped listening to me because you jumped over to Delta Math and you're trying to get a head start on your homework, you need to come back over the video for a minute. This last one is another one of these tricky approaches that could come up, okay? Notice the denominators in our last example, 10 minus x and x minus 10. You need to keep in mind that those are not the same. 10 minus x and x minus 10. Subtraction is not cumulative. Okay, you can't just switch a and b. A plus b and b plus a, those are the same thing. But a minus b and b minus a are not the same thing. They're opposites. So we actually have to, what we have to do here, and this is tricky, okay, so this is why I want to make sure I point this out. We need these two here that I just put parentheses around, but it's not showing up on your screen, and I'm not sure why. I wonder if I accidentally, there it goes. Okay, that needs to be switched around. So to switch it around, what we do is we multiply the bottom and the top of the first fraction by negative 1. And what that does is that flips 10 minus x into x minus 10. So what that does is that gives us our common denominator. So we don't need to do anything else special to get a common denominator. We just need to add like terms. Negative 2 plus 3 would be 1 over x minus 10. And that would be your final answer. So it's tricky, but in a way it's almost easier. It's definitely less work. So you need to keep your eye out for that shortcut, okay? All right, that pretty much does it here. So does anybody have any questions over this process here before I stop the recording? Any questions that I think might benefit the group? Okay, so here's the deal.